let's look at this question that we have over here. I'm going to write it down. It's tan of x minus 720 degrees, right, multiplied by cos of 720 minus x, okay, plus 1, okay, all divided by sine squared 810 plus x. Okay, so let's see, what does this look like? Well, I've got a negative angle here. I've got 720, it's outside of the Cartesian plane. I'm running around a few times. I want to make things a little bit simpler by getting within 360. So I'm going to subtract 360 as many times as is needed to get an angle that's both positive and less than 360. So I'm going to minus 360 multiplied by 2. In other words, I'm going to add 720 to this because I've got negative 720. Once I've done that, right, remember if you watch video 1 or 2 in the first set of trigonometric videos, you'll be able to see why I can add or subtract multiples of 360 using coterminal angles. So now I see that that is just going to simply be tan of x. Okay, let's look at the second one over here. Cos of 720 minus x. Well, if I minus 360 times 2, in other words, I minus 360 twice, I'm going to be left with cos of negative x. So I'm just going to leave that in there. And then there's a plus 1 that is on top, right? Which I'm not doing anything to at this moment in time. All divided by sine squared 810 plus x. Well, 810 is something I want to get rid of, so I'm going to minus 360. And I'm going to minus 360 again, right? So I'm going to say minus 360 times 2 from this. And when I say 810 minus 360, it's going to be 810 minus 720 is 80 plus, is going to give me sine squared 90 plus x. Okay, so let's just put that one in at the bottom. That's going to give me sine squared of the angle 90 plus x. Now guys, you should be looking at this and you should say, okay, this is already an angle less than 90, right? It's already an acute angle. This is a negative angle, which we don't particularly like. So when I have negative angles, what I tend to do is I tend to add 360 to it. Now when I add 360, this argument over here, or this parameter, cos of negative x, becomes the same as cos of 360 minus x, because now I've got negative x and I've added positive 360 to it. And when I look at that, I say, well, that's in the fourth quadrant. And the fourth quadrant cos is positive, and this now is part of the identity, right? And so now I simply say that that is going to be cos of x. Okay, so that's how we can simplify this part. Okay, so let's go a little bit further and let's say, well, tan x is over there. Tan x, as you know, is sine of x divided by cos of x multiplied by this thing over here, which simply simplifies, as I've shown you, into cos of x. Cos of negative x is the same as cos of x. And then there's just a plus 1 that's still over there on the side, all divided by sine squared 90 plus x. Right. Now sine squared 90 plus x. Let's see what we can do there. Let's first simplify this top. That cancels with that. I'm left with sine x plus 1. And I've got sine squared 90 plus x. 90 plus x is a co-ratio. So sine of 90 plus x simplifies into the following, right? That's in the second quadrant. Sine is positive. When I see 90 plus, I use the co-ratio, which is cos, and that's going to be of x. So let me put that in. That's going to be cos x in the denominator, right? Cos squared x. Okay, now let's see, what do I get? I've now got sine x plus 1 divided by cos squared x. Okay, so let's say this answer is of course correct, and let's say how far do we want you to go when you simplify this, right? I could write this and I say simplify this such that you write it as a function of a single trigonometric ratio. In other words, you must only have cos x or tan x or sin x in your answer. So I'm going to say, okay, what could I do? I could, for example, say this is going to be sin x plus 1, and I can't simplify that any further because this is already sine x and that's just plus 1. But cos squared x is actually 1 minus sine squared x. Right. I could go further and I can now say, okay, 1 minus, this is a perfect square, this is a perfect square. I can factorize that. So I'm going to say I've got an answer, I'm continuing from there, and it's going on over here, right? That's going to say sine x plus 1 divided by 1 minus sine x into 1 plus sine x. Right. Now I hope you can convince yourself that this part is true, that sine x plus 1 is exactly the same as 1 plus sine x, and they cancel each other out. And when those two cancel, I'm left with 1 divided by 1 minus sine x. And that is now a simplified function of a single trigonometric ratio. Good luck.